Good morning, everyone. Welcome back to my next session. So, in this lecture, we are going to discuss about some of the key points. So, initially, I'll be sharing my screen. So, these are the topics that we are going to discuss. So, actually, first we'll be discussing about what is a biometric sensor, and then what is data acquisition, and then we have to collect the input. For improving the, for collecting the input, the word pre-processing represented, and through pre-processing, I have to process with my output. The output will be the post-processing, and then most importantly, in case if it affects the clarity of the image, we have to use the image segmentation. And then we'll be discussing about the pattern extraction. There is various traits that will be available in that. We are just going to discuss only in deep about the fingerprint. So these are the topics that we are going to discuss. I will be trying to make a video lecture of all this, but it will be hardly take 3 to 4 lectures. I mean, I'll be making that into 3 to 4 lectures. So visit my YouTube channel and go through all the 3 4 videos. Then only it will be useful, because from the basics I'm going to start. So if you go through all the 3 to 4 lectures, you can understand what is a biometric input, how the pre-processing going to happen, how the post-processing, and how we can remove the noisy data. These things you can easily understand. Don't skip the 3 4 videos. It will be more important. So first we can discuss about what is a biometric sensor. So in case if you are using a biometric system, at least it requires at least one type of the sensor. This everyone knows it. So what is my main objective? We have to collect the input from the user, and then I have to convert into the language that was understood by the biometric application. That's a line it was given. Biometric sensor is a transducer that changes a biometric trait of a person into an electrical signal. So the biometric application has computer how to understand the machine language. Similarly, a biometric applications also will be understanding the machine language. So automatically it supports a values called zeros and ones. So automatically, what kind of the input, I mean, image that I'm going to take, it should be a binary image, as we already discussed in the previous lecture. And maximum bits, it will be of 1. So maximum, if it is of, it will be of zeros and ones. So depending upon the light intensity, capacitance, temperature, image, the input will be captured. So I already said, we are just going to discuss deep on only one kind of the trait. That is a fingerprint. So these are the sensors that will be using it. So there are 2 types of the sensors basically we'll be using for the fingerprint. One will be the optical and another one will be the capacitance. So in the most of the organization, so this I moved of my mouse cursor. So this kind of the device that will be used for the fingerprint, as well as depending upon the light intensity, your input will be collected. Now, we already discussed in the previous lecture what is a biological biometrics. So it is mainly used to check out the temperature if you have any fever. So you know what is the other name for the morphological? It is a physiological. Under physiological, there will be a face, finger, iris, and what we can say, biological also will be falling under the physiological. And if you take a behavioral, gait, voice, and signature will be coming. And you know, I already discussed which will be having the higher accuracy level. Physiological will be having the higher accuracy level comparative to the behavioral. So we already discussed about what is a biological. It is mainly used to take out a blood test or diabetic test, or in case if you have a viral fever or if you have a malaria, this biological biometrics will be used. Okay. And if it is a morphological, you know. So it is iris, face recognition, fingerprint, hand geometry, ear, as well as many foot retina will be used. We already discussed this in the previous lectures. So if it is a behavioral, you know, gait. Gait means footprint of the legs. And gesture means voice recognition. Okay. And another one, what is the other one? Voice. Voice is that speech recognition. I already said that physiological will be higher accuracy level compared to the behavior. Now we can move into the data collection subsystem. What is data collection? So we have to collect an input. Okay. After that, what you have to do? We have to read the input and we have to convert the data into the suitable format that will be understood by the biometric system. That's what. We have to collect the input from the user and we have to convert the data into the language that will be understood by the biometric application. What kind of the language the biometric will understand? It will understand the machine language. So the input that I'm going to collect should be a binary image and its values will be zeros and ones. So, for example, if I'm getting a very bad feedback for the fingerprint, automatically I'm moving into the face. Automatically, the presentation also will be changed. If it is a finger means I'll be using a finger. If it is a face means I have to show the face and automatically the algorithm will change. The algorithm will change from minute to what? Viola Jones window detector. I'm repeating again. I'm just going to discuss about the finger. So for understanding the concept, I'm saying what kind of algorithm is used for detecting the face. It is a Viola Jones Viola window detector. Okay, it will be detecting the window. So automatically, what is a more important is that the performance will change because there I'm going to use a finger. Automatically here I'm going to use a face. Automatically, if I'm going to use a finger, you can just keep out the finger and you can move. But in face, if the many persons are standing behind me, automatically what will happen? It will be capturing the surrounding as well. So these are the challenges. First challenge is that feature will change. And second will be the performance will change and presentation will be changing and surrounding. But according to me, most of the institutions and organization will prefer the finger. The reason is that it is very cheap and it will be very easy for the persons to keep the fingerprint. The thing is that if it is face, they will be getting confusion regarding the distance and they may not know if persons are behind. Yeah, they'll be having the less knowledge. If it is a finger, they can go to the system and they can give their input and they can move. But if you are getting a negative feedback, we know we will not be having any option. We have to make a challenge. I mean, we have to make a features to change because we got a negative feedback. Next, we are just going to discuss about the image processing. I mean, image enhancement. Okay. So first we have to discuss about what is an image. We already know what is an image. Through the image only, we are going to process with this biometric system. First, we have to collect an input. After collecting the input, in case if there is any clarity, I mean, if there is a clarity is not good, we have to remove the noise. For removing the noise, we'll be using a segmentation. And then for that, in case, if there is, for example, take an example as an iris, because we are not going to discuss deep about face, iris and all. So, but as you are learning about the biometrics, so you have to know all these concepts. So I'll be touching out some of the traits. So I already said for the face recognition, we are going to use a Viola-Jones detector. So for iris, the best example we can take is removing specular highlights. I'll be giving the demonstration for that. So you can understand about each and every type. And a region of the interest detection, we can discuss about the palm print, I mean hand geometry. So almost I said that in the initial of this lecture, we are just going to discuss about the finger. But while I'm processing with this, what I will be doing is that I'll make you understand. I will be making you understand about the different traits. So almost you'll be getting the knowledge about that. So next is the morphology because you know about that. So you are going to capture the image and you are going to remove the noise. For that, we'll be using only the physiological. Most probably, if you take a behavioral, you'll be using a voice as well as the signatures. The signatures and all, we cannot improve the clarity because signature, it should not be visible. So for image segmentation and image enhancement, the most supportive methodology will be the physiological. The other name for the physiological will be the morphological. Now we can discuss about what is image enhancement. I already said many times, image enhancement refers to the process of highlighting the certain information of an image as well as the removing any unnecessary information according to the specific needs. That's what. If you're taking an image, in case the image clarity is not good, will be improving the clarity of the image. This is the first step. And in case if there is any unnecessary stuffs are there in the image, we have to remove that. So third thing is that I'm going to take out the image. In that image, I'm looking good. My friend is not looking good. So I am going to crop that image. In that image, only I should be available. My friend should not be available. The reason is that I'm looking good in that particular image. Similarly, my friend is looking good, so he needs the his image and he needs to discard me. So he also do that. So depending upon our convenience, we can modify it. For that only, we are using this image enhancement technique. For that, we'll be using the various filters and various softwares. Next, in the image enhancement technique, so these are the various techniques that we are going to use. So image negatives. So image negative means we'll be having some original image and we'll be converting that image into a negative image. Second is the contrast stitching. What is contrast stitching is that whatever the input that we are having, that should not be a bright image as well as it should not be a light image. And it should not be a low level contrast stitching. Always, whatever the image that I'm taking should be a high level contrast stitching. Okay, I mean, it supports a histogram equalization. That's what I discussed in my previous lecture, and I given the introduction about the histogram equalization. So whatever the input I'm going to take, that should be equalized. So in case it should be equalized, the image that I'm taking should have a good clarity. It should not have any noisy data. That's what I mentioned very clearly in my previous slide. Previous lecture. So we have to be very aware of it. So these are the things that we can discuss in deep in the next lecture, because it will be taking some 10 to 15 minutes. So I'll be stopping this lecture right now. So if I start the next lecture, you can easily understand. So as of now in this lecture, we just discussed about what is image enhancement, what are the what is the data collection system, how we are going to collect the data, and what are the challenges that we are facing, and if we are collecting the input, and in which language we have to convert. Which language we are converting? We are converting into the language that was understood by the biometrics. And the thing is that the language that was understood by the biometric will be the machine language. So in the upcoming slide, we can discuss about all this. What is image negative? What is contrast stitching? What is the histogram process? Thank you. I'll be stop sharing it.